Alright, so we need to find the power dissipated by the resistor R3. Well, when the switch is open, this branch of the circuit basically doesn't exist. And if you X that out, then really this is just a simple series circuit, and the total resistance is R1 plus R3 plus R4, which is 6 ohms. And if that's the total resistance, then the total current is the total voltage divided by the total resistance, so that's 2 amps. And therefore, the power dissipated by resistor R3, well, since I total is equal to 2 amps, that means that I3 is equal to 2 amps. The same current goes through all three resistors when they're in series. And so P3 is I3 squared times R3, so that's 2 squared times 2, or 8 watts. Alright, for part B, we close the switch, and we ask what happens to the power dissipated by the resistor R3. Well, it's not completely obvious intuitively, because by closing the switch, you will increase the total amount of current that's going through this circuit, because you've decreased the total resistance. But then some of that current is going to go through R2, and some of it's going to go through R3. So you've both increased and decreased the current that you can expect through R3, and it's not obvious which one dominates. So let's do it mathematically and see. I think it's going to decrease, because you've only increased the total current by a little bit by decreasing this resistance in this part. And then you've cut the current in half. And I think cutting the current in half is going to be a bigger effect. But let's see. So first of all, if this switch is closed, then R2 and R3 are in parallel, and so I can redraw this circuit as R1 here, and then this will be R23, and this will be R4 down here, and there's your EMF. And 1 over R23 is 1 over R2 plus 1 over R3, so R23 is 1 ohm, and the total resistance is 5 ohms. So as I figured, the total resistance compared to up here, the total resistance has gotten lower, and that means the total current has gotten a little bit higher. It's 12 over 5 now, so that's 2.4 amps. But now I need to consider what's happening with R3. So the voltage drop across R3 is I23, R23. And of course I23 is I total since they're in series. So we take 2.4 times 2, which is 4.8 volts. Alright. Oh wait, no, I'm sorry. It's 1, isn't it? Oops. Sorry about that. Yeah, R23 is 1 ohm. So that's less, right? Up here, the voltage drop across R3 when they were all in series, well, the total voltage here was 12, so each one of these had 4 volts, 4 volts, 4 volts. So now the voltage drop across R3, instead of being 4 volts, is only 2.4 volts. And so that's going to decrease the power. Power dissipated by R3 can be written as delta V3 squared over R3. So that's 2.4 squared over 2. So that's 2.9 watts. Whereas before we were doing 4 squared over 2, which was 8. So P3 decreases compared to what it was before, which was 8 watts.